Good afternoon. According to the program, I'm supposed to speak about some high-tech stuff on share our knowledge on AI and other smart technology that machine builders know about. I had to change the program a little bit, and this is actually the title of my new presentation: Where on Earth Have the Flowers Gone? Each and every one of you here in the room is well connected to the industry. And it will come as a surprise if you don't know the pressure that growers have on labor, the cost of input resources. These are real nightmares that keep them awake at night. And if you haven't heard about them, you might consider a career switch, because this is all over the planet what keeps them awake. And the sub-question about that is, where have the people gone? I don't know about you, but in my daily life here in the Netherlands, well, just across the border in the Netherlands, whenever ordering a coffee somewhere in a coffee shop or walking into a shop, the number of times that I have to switch from Dutch to English doesn't cease to amaze me. Where have the people gone again? We have, of course, laborers, but apparently not the people that used to be around to do the jobs. These are some headlines from across the globe, and it is, of course, a trend from all over the world. Just a few facts that I'm sure you're aware about. But like in North America, for instance, Bill, Victor, you know about it, 20% labor shortage is what growers tell me there. Latin America, in Mexico, it's a matter of migration. It's a matter of urbanization. Growers that used to be close to cities that grow, where workers now have the option between working in a greenhouse with 40 degrees, 50 degrees, or working in a retail store somewhere downtown without getting too sweaty. They choose the latter, so growers have to increase the pay in many cases. And it's no different in Africa, in Colombia and Ecuador. Augusto is not here. These are really big issues. And in Europe, and that was kind of a shocking thing for me, we are losing so many people in the primary industry. I expect in 20 years' time that we've lost about 30 million people in our workforce. That's almost 10% of our total workforce. And if you put it into perspective, we would have to start cooking our own meals, because 30 million people is part of all the chefs and people working in restaurants. The entire agribusiness, we would be out of a job. There would be no food production anymore. There are about 8.9 million in the primary industry in the entire of Europe, and roughly the same number in Europe in the food service and hospitality. So it's a hell of a lot of people, and they're gone. So what would be an option? This would be the nightmare scenario, of course, of every grower and retailer. But it's already happening. I don't know how you see that in your markets. I travel a lot to Latin America, and in Brazil, a couple of weeks back, a grower told me that he's leaving 25% of his production empty because of lack of labor, obviously. But no matter how we put it, hands are still involved in every flower and plant that we buy. The hands have become scarce. In the old days, it was more or less a complete different ball game, of course. There were the people, but the production was very amateuristic, I should say, almost. It was to the best of their knowledge, but if you compare that with today, the production efficiency is, of course, order of magnitude in difference. So a worker like that would be planting roughly, say, a couple of thousand of bulbs, tulip bulbs per day. And this was a big business in those days, of course. Perhaps you've heard of the tulipomania in the 1600s. Was the first stock market, informally then, for which was based on the trade of tulips. Nowadays things go a bit different, of course. Here we see an example of what a machine of our company does. And here only a very small number of workers are processing around 80,000 flower tulip bulbs in this case every single hour. But that production volume and efficiency is not everything, of course. It's the advantage of the technology leap that was made here is also about collection of data. And that will be, I think, one of the key value propositions that we have to make, that we can make and will make. Someone eventually has to observe a plant, a flower, and collect the data on that. Otherwise, AI, machine learning, might not be so valuable because you need the data, obviously. Oh, there's sound. I didn't expect sound to come out of this thing. What you see here in a very brief note is top right is a vision analysis of a flower bulb as it passes through the vision cabinet down right. That's where we make the 3D image and compose, let's say, a digital twin almost of every individual bulb. Around 12,000 bulbs pass through that cabinet when the machine is at full speed. And next we plant them in a specific orientation where we filter out the bulbs with anatomic defects or with a specific SAR bacteria disease in bulbs. So let's switch briefly to a quick commercial then of our company. We've started out around roughly 20 years back based on the question of a grower. The grower wanted to automate the planting of chrysanthemums in his greenhouse. And these chrysanthemums, they come, of course, as you know, as small cuttings from East Africa. They're rooted here in the Netherlands, and eventually after rooting, they have to be planted in the greenhouse. It was done by hand, and now 100% of the growers quickly switched to planting with this robot. We're about with the next generation now, not because the next generation is necessarily better. The next generation is obviously better, but not because the machines were outdated. All of these machines actually, even after around 20 years, are still running. This is not really new, and again, if this is new, that would be a surprise to me. These trends actually enable our business, of course. The lack of labor is an opportunity for us. Rising energy cost, same thing. If you have a greenhouse that is not filled to the absolute maximum, that waste of a couple of percent will cost you money. Because you're heating it, you're watering the plant, you're treating it, but it will result in nothing. So every aspect of this is actually good for us. So you can come talk to me later on, of course, and we'll gladly help you to one of our solutions. This is a brief oversight of what we do in the plant's journey. We're about to add, before the planting even, the harvesting of cuttings. And we've recently added, towards the end, the harvesting, in this case, tomatoes. And you might see other harvesting solutions for crops as well soon. Quick overlook in our company. You might have known or know the two separate companies, TTA and ISO. Beginning of this year, we merged and joined our forces. And to our surprise, that's working out really well. because it turns out that we have a very complementary portfolio. We thought we were hard competitors, but the reality is luckily different. So there's a lot of synergies, and also I think for clients of ours, life becomes a lot easier. Now we're spread across the globe, not extremely relevant, but good to know that clients of ours have always a service engineer in close proximity. And how we will see the future is that it's always about improving the operational efficiency, no matter how you look at it from what perspective. I'll take you to a quick video of pictures are better than 1,000 words. You'll see an impression of the equipment, and later on we'll get back into so planting cuttings is one of the came quickly after introducing that RoboPlant machine that we just saw. We're looking at the facility of Florensis here, well known to most of you. They operate 35 of these machines for the majority of their portfolio of hundreds of different crops and varieties. So that indicates kind of a flexibility of the equipment on dealing with a variety of anatomic properties and features that you can see by vision. So every single cutting is identified while it's presented to a camera, and we measure specific criteria like cutting length, number of leaves, the stem diameter, and with a variety of machines, not with this one, but we can decide if you can decide as a grower if you should plant that cutting or discard it or plant it in different classes. This is a machine that's very suitable for monocrops. There are a couple of hundred of machines in operation. One of the big breeding companies, like Daily Vlog, they have a huge facility in the center of Holland where they also plant the varieties of their competitors, like Dumen Orange, Floritec. This facility plants almost 800 million chrysanthemum cuttings and roots them, of course. And I have an installed base of 42 machines. They run 21 hours a day with only 6 operators. So 6 people plant almost 800 million cuttings on an annual basis. These machines are obviously interlinked. So if the first machine of a line detects a difference in a particular variety, and if that difference is detected multiple times, then the software behind it, machine learning, can start to adjust on decisions whether to plant or not to plant a cutting. These are anthuriums. The company Antura, number of growing stages. They want to analyze the quality of the plants that they're growing. Anthurium takes, I believe, over a year to cultivate to a young plant. So it's a very expensive game if you will have dead plants in your nursery. So we filter out the bad ones based on the green area, the number of leaves, the number of shoots, the root structure, the root volume, and of course the color. And particular varieties or crops have the tendency, of course, to genetically jump back to one of the parent lines. So a different plant in a batch of varieties would stand out, and we would recognize that, of course, as well. It's a highly reliable way of analyzing your crop. We get about 99% accuracy then. One of the other cool things is a grafting robot. And I know, besides some trees and shrubs representatives, there's not much grafting going on. And also for open field tomatoes, that's very new, because that's what we're looking at here. Greenhouse tomatoes have been grafted forever since. But for open field, the two reasons why to do it. This is in California, by the way. It's one company, California Master Plant. They have around 350,000 hectares of open field tomatoes. They have roughly 10% share of the world market for industry tomatoes, and are the main supplier of the Heinz Royal Kraft. They used to seed the tomatoes in the field, but there's a particular virus, the broom rape virus, and there's a drought challenge. So they would need preferably plants with deeper rooting and with resistancy, of course, to that particular virus. When seeding, that's impossible. So when combining the rootstock and a scion plant, the best of both worlds is achieved. And the production goes up again from 40 tons per hectare to over 120 tons per hectare. So in this case, a machine has a payback of only 4 months. So this is a multi-million-dollar investment. It's absolute no-brainer to switch to grafting. Similar in cacao, for example. That's what we've started grafting, but then you'd need to switch, because it's a lignified woody crop, to micrografting. And we're doing the same for coffee and palm trees now in Brazil. Is one of the tulip bulb planters, and by now, since last week, I can proudly say that 100% of all tulip growers in the Netherlands has one of these machines. Actually, a line of machines, because on average they go around 60 to 100 million tulips per season. And these machines only operate for 2 to 3 months per year. And the payback is again less than 2 years often. And it's not only about labor. I have to keep stressing that. It's not only about labor reduction. This is about uniformity, consistency, quality of output, reducing the inputs. And that's often where the economics weigh in the heaviest, not necessarily on labor reduction. Well, that was about it. A brief touch upon robots, because we see moving stuff, these SCARA robots, and we think it's a robot. Yes, it is a robot, that's what it's called. But to no extent it is somewhat autonomous. This thing simply only does X, Y, Z coordinates. That's it. If you see these robots in car factories, or it's only X, Y, Z, nothing else. Someone has to tell them where that specific coordinate is, how to move something from one position to another one. And luckily, in very consistent production environments like a car factory, that's quite easy. When working with a natural product, you know as no other, that's where the challenge comes in, because nothing is similar. Everything is unique. Nonetheless, robots are, of course, penetrating mainly the industry domain. The interesting stuff here is that China is installing over 50% of the world's robot. Installed base is much bigger, but annually they still install, or you're still installing an enormous volume of robots. And you know better than I, but labor, again, availability, but also the preference of the workforce. The choice of working in a factory or working elsewhere is what drives the trend. And to the credit of the Chinese strategists, so to say, they're anticipating. They're anticipating on what we still need to see almost. They're anticipating on a world with less labor, or labor with very specific preferences. And they're investing ahead of the curve. And we in horticulture have been lagging behind, but we're catching up. By coincidence, actually. Oh, sorry. By coincidence, this is in China as well. A layout of a big factory growing young plants either from cuttings or from seeds. And this is particularly wanted to show this because we have been implementing robots in existing environments. And we've not been considering building a complete new line often. And by we, I mean the industry as a whole. We've been adding robots, automation here and there. The next step is the complete turnkey design and start with the process rather than with just the greenhouse. So the robot is really a mechanical movement driven eventually by the software, which is actually the data generator. It has to collect the data and instruct a specific action. With AI, and I haven't put anything, or hardly anything about AI in here because there were a lot of smart people before me, the transformation of data into something actionable and defining what then the smartest thing would be is, of course, the role what we do. And currently, I must confess, it's not really exciting. This is only machine learning. That's the very basic level of AI that we currently do. It has the potency, though, and the infrastructure is there, but it's very basic stuff. Realistically, we have to be very. The image of robots is not what practice is actually. Like a sister company of ours, this is Aero Farms in the US. These Wall Street boys have been collecting millions and burning hundreds of millions of dollars by making a very cool marketing story, while in essence, the whole production is only about temperature, humidity, and light. Some successful examples, harvesting trees. This is really a drone, 6.5 meters diameter, harvesting a tree out of a forest. Why is it successful? Because if you detect a disease in a certain area of the forest stand, you can target that one specifically without having to move that tree all the way through the forest and infecting others. This machine we've just seen, but it's something very interesting for ornamentals because it collects data. And that's the touch point on AI, so I wanted to show you what we actually see with our machine. And what we cannot see, we cannot collect data or analyze. So on the bottom right, you see a structure of a sugarcane plant, differentiating the roots and the green area. Most plants we make a 3D image of. And when the 3D image is there, we isolate the specific components that a grower wants to see. And that grower eye, of course, is still needed because eventually the grower has to teach the machine. Someone has to teach what is good and bad. You can say, well, we can detect a color, or we can detect the number of leaves, or we can detect a certain gradient in the stem. But someone has to tell the algorithm on if that's good or bad, or within certain bandwidths that are acceptable. So, will AI and robotics take over? Yes, they will have a huge impact. Will they exclude the grower? I'm convinced, no way. Will they exclude all the labor? No way, because we still need people to organize the process and to annotate the robots. So eventually it's not about a hype, about a marketing story. It is about simply adding value in the spots where we can. And that's humbly what we as a company do and think we can help you with as well. Hopefully soon Leonardo can count himself among our clients as well. So, well, thank you for your time, gentlemen and ladies and gentlemen. This was a movie. I will skip that one because of time. Thank you for your attention.